students, this is Miss Shayma Gharib and today's lesson about one-whole fractions. Let's start. Some rules before you watch any video. First, sit in a quiet place. So you have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve the questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start our lesson. Write the shaded part as a fraction. Do you remember from previous lessons how do we write shaded parts as a fraction? Let's remember together. The number of shaded parts over, what do you think? Do you remember? The total number of parts in one whole. So to write the shaded part as a fraction, we write the number of shaded parts over the total number of parts in the whole shape. Let's see the first shape here. Look at this shape. It's all shaded. So let's count on the number of shaded parts. 1, 2, 3, and 1, 2, 3, 4. So 3 times 4 equals 12. So the shaded parts are 12. Okay? And what about the total number of parts? It's also 12. So our fraction here will be 12 over 12. So this is how I can write this as a fraction. What about this one? We're going to do the same steps exactly. 1, 2, 3, 4, 5. 1, 2, 3, 4. So all the parts are 5 times 4, which is 20. So all the parts are 20. And the number of shaded parts also 20. So this shape will be 20 over 20. What about this one? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6 times 4 equals 24. So all the parts are 24 and all of them are shaded. So the fraction here will be 24 over 24. So what do you think? If I look at any of these shapes, I will find that all the shape is shaded, which means number one, it's only one shape. And here it's only one shape. And here it's only one shape. So all of these fractions equals to one whole, which is number one. So I want you to look at this fraction and notice the number of numerator is same as the number in the denominator. So now, do you know how do we express one whole as a fraction? It's always up and down or the same always, okay? Now, let's go to the next. How many halves are there in one whole? Think, how many halves are there in one? Yes, there are 2 halves. Excellent. Now, how many thirds are there in one whole? If I have anything like this, any shape, and I want to count the thirds, which means I will split it into 3 parts. So how many thirds are there in any one whole? 3 thirds. Okay? But what about quarters? How many quarters are there in one whole? The same, if you have a shape and it's already split it into quarters. Okay, so how many quarters are there in one whole? Of course, as you can see, 4 quarters. What about how many fifths are there in one whole? Same exactly. What do you think? There will be 5 fifths in one whole. Now, do you notice how do we find parts in one whole? 1 whole as a fraction. Write some fractions that equal to 1 whole. Now, I want all of you to stop the video and start to give yourself some examples. Write, for example, 4 different fractions that equal to 1 whole, and then play the video, okay? Fraction 4 over 4 or 4 quarters equals 1 whole. 11 elevenths or 11 over 11 equals to 1 whole. 8 over 8, 8 eighths equals to 1 whole. 3/3 equals to 1 whole, and so on. So how many fractions we can write? We can write an infinite number of fractions that equal to 1 whole, okay? Now, let's see. Write the shaded part as a fraction. Do you remember how do we write the shaded part? Shaded parts over the total number of parts. The shaded parts are 5 and the total number of parts is 12. So the fraction here will be 5 over 12. Look at this question. What fraction is not shaded? Look at the parts that are not shaded. 1, 2, 3, 4, 5, 6, 7. So if I want to write the unshaded part as a fraction, it will be 7 over 12. Now I have 5 over 12 shaded parts and 7 over 12 unshaded parts, right? Okay. How many parts are there in the whole shape? The total number of parts in the whole shape is 12 parts. Okay, what do you notice here? The number of unshaded parts and the number of shaded parts together, they form the total number of parts. 5 plus 7 equals 12, and they both form the whole shape. So if I added the shaded parts to the unshaded parts, I will get 1 whole. 7 twelfths and 5 twelfths. The total number of parts will be 12 twelfths, which is 1 whole. Okay, do you understand this? So when we add these two numbers together, 5 and 7, we will get the number in the denominator, okay? To form the 1 whole, as we said before. We just link it to making 1 whole. Now, look at these two numbers. As you can see, they form the number in the denominator. Let's see this. The sum of all numerators must equal the total number of parts. So when we add, sum means that we total or that we're going to add. So when we add all the numerators together, they must equal the total number of parts. When we form or when we have 1 whole. For example, here I have 3/8 plus fraction equals 1. If I asked you, how many eighths are there in 1 whole? There is 8 eighths, right? So, I only have 3/8. So, how many eighths are left to form 1 whole? If I have 3/8 and the 1 whole is 8/8, so the rest must be, yes, 5/8. Another way, we said the sum of all numerators must equal the total number of parts. I have here number 3, and the total number of parts is number 8. So I need a number here. When I add it to the 3, it gives me 8. 3 plus what gives 8? Of course, 3 plus 5. So the missing fraction here will be 5/8. So 3/8 plus 5/8 equals 1. Now the total number of eighths is 8/8, which is 1 whole. Is it clear? Let's see more example. What do you think? 7/15 plus 8 15ths equals 1. Is this correct? Let's check. 7 parts out of 15 parts and 8 parts out of 15 parts. So the total number of parts here, 7 plus 8 equals, yes, 15. So which means in total I have 15 15ths, which is, do you remember? 1 whole. Okay, so let's check this rule. 8 plus 7, 15. So the sum of all the numerators must equal to the number in the denominator, which is the number of the total parts. So 7 plus 8 equals 15. Yes, so that's correct. Now, let's see this example. I want you to think of this example. This time I have 3 fractions. 1 6 and a missing fraction and another missing fractions, and the 3 of them must equal 1 whole. Okay? So what do you think? 1 out of 6 parts. So the total number of parts, or all the numerators together, must equal number. What? Must equal the total number of parts, which is, what is the total number of parts here? Number 6, right? So must equal to 6. 1 plus what equals 6? Of course, 1 plus 5 equals 6. This is the 1, so I need these two numbers to be 5. There are many answers here. I can write them as 1 and 4. So now the total number of parts is 1 plus 1 plus 4 equals 6. Or I can write them as 2 and 3. 1 plus 2, 3 plus 3 equals 6. So at the end, the total number of all the numerators must equal to the 6 to make 1 whole. What about the denominator? It should be the same, because the denominator always the number of parts in 1 whole. So the number of parts in 1 whole, the total number of parts is 6. So it will be always 6. Okay, is this clear? So we can answer it many ways. Now, are you ready for the questions? Let's start our questions time. Making 1 whole. You have here 6 examples. I want you to stop the video and start to do it by your own according to what did you understand from today's lesson, and then play the video to check your answers. Let's start. 1/4 plus what gives 1 whole? It's very easy one. We said the total number of numerators must equal to the total number of parts, which is 4. So 1 plus what gives 4? 3. So the missing number here will be 3/4. Don't just write 3. Okay? We are collecting the quarters. So 1/4 and 3/4 equals 4/4, which is 1 whole. All right? 2/3 plus how many thirds gives 1 whole? 1 whole, we said 3/3. I only have 2/3, so I need 1 more third to get 3/3. 1/5. If I want to express the 1 whole in fifths, it will be 5/5. I only have 1/5, so we said the total number of numerators must equal to the total number of parts, which is 5 in this question. So 1 plus what gives 5? Plus 4 and 5 as our denominator. So 1/5 plus 4/5 equals 1 whole, and so on. So the total number of fifths here is 5/5, which is 1 whole. Now, what about this example? 1/8 plus what? I have 2 missing fractions. So here, the 1 whole, I can write it as how many 8s are there in 1 whole, because this is over 8, so I'm asking about the 8s. So how many 8s are there in 1 whole? 8 8s, as we said before. This is how do we write the 1 whole using 8s, or what whatever the fraction is, okay? So now I only have 1/8. So how many fractions I need to make all the parts 8/8? I have 1, so I need 7 more. So these two numbers must be 7/8 in total. So I have the only 1/8 and I need 7 more 8s. I can split this 7/8 into two numbers as 1 and 6, or 2 and 5, or 3 and 4. All of them are correct. So I can write this as 2/8 and 5/8, or 1/8 and 6/8, or 3/8 plus 4/8. So the total number at the end, the 3 together, must be 8 parts out of 8 parts to form number 1. Okay? What about this example? 5/6. 5/6. The total number of parts is 6. So the 1 is 6/6, or 6/6. Now, how many parts do I need, or how many 6 do I need to complete one whole? I need only 1, because these two numbers together must add up to 6. Okay? This is a number, a different number. It's a bit larger than before. So 13/25. So the total number of parts is 25. And if I want to write number 1 as a fraction over 25, it will be 25/25, which means these two numbers together must be 25, right? Okay, so 13 plus what gives 25? I can get this number by subtracting it. 25 minus 13 equals 12. Okay, is this clear now? All right, now let's move to the next. How many tenths are there in one whole? What do you think? How many tenths? Which means a fraction over 10. 1/10. So how many tenths are there in one whole? Do you remember when we said how many halves, how many thirds, how many quarters? Yes, so there will be 10 tenths in one whole. In this example, Harvey cut 1/9 of his birthday cake. He shared the rest equally among his two best friends. What fraction of the cake each friend get? When we have a story problem, we have to read it part by part, then start to translate it into math. Harvey cut 1/9. What's the meaning of 1/9? It's 1 part out of 9 parts, or 1/9. All right? Which means this cake is cut into 9 parts. All the total number of parts, or all the parts, are 9 parts. And he cut 1 part out of the 9 parts, or 1/9, as you can see. And what do you think? He shared the rest equally among his two best friends. There are two important words here: rest and equally. Shared equally and rest. If he cut 1 part out of 9 parts, so how many parts are left to form the one cake? I have 1 whole cake. He cut 1 part out of 9 parts, so the rest will be, what do you think? 8 parts out of 9 parts. So 1/9 plus 8/9 makes 1 whole, which is the cake. What did he do with this rest? Let's see. He shared the rest. So he shared the rest equally. Shared equally. among his two best friends. So he has two best friends and he's going to share the 8 parts, the 8 nines among them equally, which means each one of them will take 4 parts, right? 4 parts out of 9 parts, or 4 nines. Is this clear now? Let's see the next example. Mazen ate 1/5 of his apple pie. What fraction of the pie is left? So he ate 1/5. This is what did he eat? So 1 part out of 5 parts, and he has only 1 pie. So the total number of parts is 5, and he ate only 1 part out of 5 parts. So what fraction of the pie is left, or how many fifths, or how many parts are left? So we said the total number of parts must be 5, and this is only 1 part, so there will be 4 parts left, which is 4/5. So that the answer of the question will be 4/5. This is the fraction of the pie he left, okay? This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. See you next video, and please remember that your feedback is highly appreciated. Thank you very much and see you soon.